Hello and welcome to another episode of Low Pressure Area with me, Jamie McDonald.
And with me, Richard McKay.
And it's that time of the month again, Richard, that we're back talking about all things weather. And this week is quite an exciting one. And I think I've said that every week, but I really do get excited putting these together. We're talking about precipitation. And I think some would argue that precipitation, along with temperature, are kind of two of the most potentially important meteorological phenomena that we measure, because they both really have quite a strong effect on climate patterns as we look forward as well, and generally on everything else that happens. Something you could argue with maybe, and I'll let you argue with me on that a little bit later if you think that's the case. But it's certainly something that has a big effect on our day to day, and often, as you said earlier to me, when people look out the window in the morning and wonder what the weather is, they're often looking to see whether there's something falling from the sky or not, or whether it's a sunny day or not. And I think maybe as a kind of nice intro to this, I'll throw the question over to you. Is when people look out the window in the morning, are they actually looking at precipitation? Are they looking at present weather, or are they looking at something else? What is it that they're really looking at?
So yeah, it's definitely one of the main parameters. I guess there's typically 5 that are captured as the fundamental parameters to understand the conditions and forecast forward, which usually people are trying to capture data or understand situations is to make an assessment and then decide, on future action. I will say that temperature is certainly probably the most fundamental, and then it could be a whole discussion about this, but it could be wind or pressure tends to be sort of the next ones, but precipitation is not far behind it. So to your great starting and intro to the topic precipitation. I guess I'll share my screen again, as we've talked about in the past. A few slides that accompany this, and hopefully they supplement what we're talking about. We do try to cover the main points when we're in the audio elements for those just listening, but where possible, then it's great to have some visual elements to look at as well and understand and explain things a bit further. So I've got an image on the screen, and it's really got small, medium, and large particles, some in focus, some out, some liquid, some frozen, that appears to be in the image. And I guess that comes to that point about what is that? When we look out, we typically are trying to say, is it wet or dry? Can I see a long way? Is it sunny or not? These kinds of things. And for this talk, we're going to really focus on precipitation rather than present weather. Present weather just is covering an awful lot more, and we'll go into depth on that in another episode. But really focusing on precipitation, and then just try to, again, for those that are following along, the difference is that precipitation covers the hydrometeors, which is more or less moisture wrapping around particles and either suspended in, falling down, or other things that are happening to it, like being picked up by the wind from the surface or being spun around in a vortices, which you'll see in a minute. But those are known as hydrometeors. And then that's covering more or less the precipitation aspect. Present weather covers more state of the ground, includes dry particulate as well as a few other things like how far can I see and what's causing that. So that's coming up in another episode. But maybe to follow the same format we've done in the past, talk about definitions and the etymology of the words. So precipitation, I've got quite a bit of info on this visual slide for those that do want to look at that. But again, 2 big references here that we always try to include and put links in down below. One is the WMO, World Meteorological Organization's International Cloud Atlas. And you'd ask, why is precipitation or present weather in a cloud atlas? But it tends to be a reference that's used to give very good visual clues for those that are looking to see what am I seeing, and how does that compare to a reference photograph or digital image that I've had? So that's again sort of a screenshot, and I've covered sort of those 4 crazy classifications. One is, as I was paraphrasing, and I'll come to the definition in a second. And then the second reference here is the glossary of meteorology. We've not talked about that, and could be an episode in its own right. But if you ever want to know any meteorological term, there's a free online reference called the American Meteorological Society's Glossary of Meteorology. It used to be in a book and quite expensive, and now it's a free online tool, and again, links to that. But there's a definition there. And interestingly, when I looked at both dictionary references as well as in sort of these tools, there isn't one universally agreed definition. So it's very much in line with precipitation that, gosh, it's one of the most flexible, I guess, things that we measure in terms of the time period that we're measuring it over, the way that they're defined, how the definitions are done. They tend to vary regionally and everything else. But to come to it, various definitions, they effectively all suggest that these hydrometeors, as I described them, that form in cloud, which can include fog, either deposit or are suspended in that cloud or fog. So there are precipitation events that are suspended and not falling through the atmosphere is an important bit here, as well as things that typically, precipitation that we think of most of the time, are falling through the atmosphere through effects of gravity. And then there are two other areas which we don't tend to think of too often, and that is where something that the hydrometeor that's been picked up by the wind from the surface, and you can think of snow here, and blowing snow is a precipitation event, but it's not falling down through the atmosphere. And then the last one, which kind of surprises me because it's not in classical sort of element, but the World Meteorological Organization classes them as things that are formed by vortexes or vortices, depending on your area of the world you're in and how you describe this in plural. But you know, a funnel cloud, a waterspout, or a tornado is effectively classed by the WMO as forms of precipitation, believe it or not. So those are the four different ways that they're classified in a general broader context. And then, like I said, in the typical area, it's usually what's falling down through the ground. So appreciate went on quite long on that aspect, but quite important because it varies quite a bit. And then the etymology
Sure.
of the word. Again, I didn't know this until I looked it up, which is a bit of a shame. After 40 years, you'd think I'd try to figure out why on earth are we calling it precipitation, but
Learn
it
something new
forms
every day.
exactly. Every day is a school day. So it forms from the Latin precipitare, which is interesting and means to fall headlong. So, you know, interesting that I guess, especially most of the precipitation that we are interested in it is quite heavy rain showers or hail, and that, as you can imagine, with force and be hasty, that kind of aspect is involved. And I should state, as always, where we've captured things, we've tried to reference where we've got those and include links and say that the copyright is obviously respective of those owners. So that's in a nutshell, difference between present weather and precipitation and the definition and the etymology of them.
Yeah, that's quite fun, right? It says to fall headlong, because I was in Norway, west coast of Norway last weekend, up on a mountainside in very strong winds where there was a waterfall being blown upwards. So the precipitation was definitely not falling anywhere headlong, but rather flying upwards headlong. But fascinating history. Kind of also reminds me, and I've said before in this podcast that I'm based here in Finland. And we're talking about the different definitions and the fact that people can't quite agree fully on all the different definitions. Reminds me also from a language perspective how many different words there are for different types of precipitation. Finland, for example, as many of you might know, often has pretty snowy winters. And I was born in the UK where we've got, and we'll look a little bit closer at in a second, only a few words to describe snow, right? There's kind of snow, slush, sleet. There's probably a couple more, but not all that many. And I moved here to Finland, and Finland's got at least 20 different words for snow, describing down to little minute details exactly, well, this slush is only slush that appears over +5, but less than +10 degrees Celsius, and then it's falling from the sky at something else. So these kind of cultural differences are really fascinating to look at as well. I think really what we've talked about so far is that, yeah, there's all these different versions, and there's some that stay in the clouds and some that fall and some that fly upwards, even as we've just mentioned. Can we look a little bit closer at what those different types actually are and why they're important, I suppose, from a weather perspective too?
It's a good point. And yeah, we didn't go into too much detail, but I wanted to cover this, and it's one of the points that I've got here, and I won't go through everything on this slide, but as you said, an interesting sidebar to that bit about the Finnish 20 words for snow. When I grew up as a kid in northern Canada above the Arctic Circle for a couple of years, I found out that I believe, I might have the number wrong, but it's certainly more than 1,000 I believe the Inuit have over 2,000 words for snow, the different types of snow. So obviously very crucial to a lot of the, like you said, not only the, the conditions, but the cultural or the other hunting aspects or things that go along with that. But traditionally, I'll say that we could define it a number of different ways. To come to the point, I think that and keep this particular episode fairly short and brief and snappy. We look at three different types. So whether it's liquid, freezing, or frozen. And with the liquid, everybody tends to know what drizzle and rain are. I'm going to suggest that drizzle is erroneously classified by a lot of people because actually the definition of drizzle is that you can only discern drizzle by moving yourself through the drizzle. Whereas if you can see it falling or you feel it appreciably sort of hitting your skin when you stood still, then that is rain. And anything that's drizzle, you must actually move through to accrete. And that's the definition, basically. So again, that varies by region and by country. But freezing, again, I'll say there's a couple of, slight variances on this, but everybody knows sort of freezing rain generally, what that looks like. But the real area that's interesting is frozen. And as you mentioned with snow particularly. So really there's snow grains, ice pellets, snow pellets, hail, and diamond dust, which I'm sure not too many people have heard of. They'll have experienced it, I think, at some point when they've looked up in the sky, but maybe not known what it's been called. And again, for those that are looking at some of the visual clues that we're providing in the slide deck that we're providing, you can, when you see that arc of a rainbow and it's not raining, and so a critical point here is if the sun is behind you, almost always when you see an element of a rainbow or a spectrum of the light prism broken out, then that's actually a rainbow effectively, or a section of a rainbow when the sun's behind you. If the sun is in front of you and you see an arc of the light spectrum broken out, that's actually diamond dust. So, and can go into that in a second, but there's a small image of sort of an arc where you can see it, and there's typically at certain angles where you will see that when it's occurring in the atmosphere. But snow grains, ice pellets, snow pellets, and hail. And why are those important? So again, this is where the meat of the discussion we want to talk about today, and we'll talk about it again audibly, but where you can really does make sense to look at the visual slides because it really gives a nice representation as well. And to come to the point of why isn't it just called snow and hail, for example, just those two? It really comes down to what's happening in the atmosphere. And you'll appreciate these days we have measurements from everywhere. And, there's satellite measurements, there's measurements from your car, there's measurements from the surface, whether those be rain gauges or, the other things. But sometimes they're not all being provided to all the same places and you don't always have access to them. And of course, there's a historical element to a lot of data collection. And the really big thing to know about is depending on what's classed as frozen precipitation is letting you have an awful lot of information about what the atmosphere is doing. So if it's unstable, if it's a stable type of cloud, if something is changing. So if you're going from something, let's say, fairly innocent to something that's much more sinister in weather terms, then you may not go straight from no rain or no precipitation to hail, for example. And so you'd want to follow the evolution of, let's say, rain to rain and snow mixed. And is that rain and snow from a stable type of cloud, or is it rain and snow from an unstable type of cloud, then to rain and snow and hail, which would mean possibly other dangerous to aviation and other users. So snow grains are really the smallest. They're the equivalent of drizzle. They're less than 1 millimeter in diameter, really tiny specks, typically spherical in shape, so much more round and that familiar sort of form. And then they don't bounce on impact. And again, they really come from stable cloud. So it's a good way to discern, is it a stable innocuous type of event roughly, or is there something more, coming along? Snow pellets, which is coming next after that, if you will, is again what a lot of people would typically call snow when it falls, but a lot of the time you'll see snow grains rather than snow. And actually, I just realized I don't actually have a picture of snow in the slide deck. There's all these other exceptions, but not snow per se. But snow is a crystalline structure. and it has, effectively almost like these tentacles going out with these crystals forming off, and they tend to be repetitive in nature, but they can be unique. Every one is unique, whereas snow pellets are much more uniform. They're usually that round shape, like a clump, almost like hail, but not having the shiny liquid outer layer, if you will. And they tend to be more hollow inside. They can be up to 5 millimeters in diameter, and appreciate these are all metric dimensions, so apologies to those in the imperial world. But they fall from convective clouds. So again, it's letting us know that there's more activity in the atmosphere. There could be turbulence, could be icing, could be other things that you want to know about. And then hail, the classic one that most people know, that can be typically it's classed as anything that's bigger than 5 millimeters, and it can go up to, I'm going to say up to possibly even a foot long, or 30 centimeters. There's a new class of hail even called gargantuan hail, which extends from 14 centimeters up to, which is almost 6 inches, up to, anything bigger than that, which is crazy when you think about the mass of something like that being transported in the atmosphere.
Yeah, it's scary if it hits you as well, I'm sure.
Yes, well, that sort of hail could certainly damage and kill people. But that's, again, a convective type of precipitation, and it's a liquid sheen because it's melting as it comes down through the atmosphere, and it's sort of concentric layers like an onion, so much more solid sort of structure, and that has a central sort of opaque core. And then ice pellets, again, are something that happen quite often. Not too many people class correctly. They'll roughly call it snow. Tends to be more transparent, and it's a bit harder to see in the image, but it's one where you look and you can see almost right the way through. So it's not maybe crystal clear, but it's definitely translucent and translucent. And those, again, sort of less than 5 millimeters in diameter. A lot of precipitation in the atmosphere can only be up to about 6 millimeters in diameter, just due to a number of factors that we can't go into in this podcast, maybe in another one, but that's sort of the limitations. Hail tends to be the exception, which can grow enormously beyond that. And then the diamond dust we talked about, which is completely on the other end of the scale, and is ice crystals that are frozen. They're actually falling through the atmosphere, but because they fall so slow, they almost look like they're suspended in the atmosphere, and that's why they then can sometimes break out the light prism when the sun hits at particular angles. So those are 100 micrometer, and so basically micrometer is a millionth of a meter. So certainly very small, and again suspended in the atmosphere. And those typically again are in clear air, so not any cloud around, and they are just a section where the air mass cools extremely quickly, and then some crystals form and fall down through the atmosphere very slowly. So, but all of those give us a better picture about, is it a convective or a stable cloud, and is it leading to, or is some situation dissipating from a particularly challenging weather situation that people would want to be aware of. So that's why the frozen elements are much more critical, and affects obviously aviation and other users particularly.
Yeah, I can imagine. And this is also super interesting to see that these all have names, right? Because we've all seen these, I think. Well, not all. Most of us perhaps have seen these. I did have friends I remember at university who'd moved from the Southern Hemisphere and never seen snow before moving to Scotland, and that was quite something. But they actually give them a name. Particularly, I'm looking here at the snow pellets. I see these fairly often, and I've just called them snow. So to know that they're actually snow pellets is really pretty cool. I think you've reminded me, and I'll say this, while I was researching this episode, I was looking at fun facts, and we'll get to that in a minute, about precipitation. And the diamond dust reminded me. I read somewhere, and those of you listening, please do your own research here. This is my own caveat that I wasn't able to find whether it's true or not. But I read that some researchers in the US had hypothesized that on Saturn, the planet of Saturn, where the atmospheric pressure is so high and the level of methane in the atmosphere is so high, that as the methane kind of falls down towards the surface of Saturn, the pressure crushes it, and particularly the carbon in the methane, so much that it could, in theory, rain diamonds down on the surface of Saturn. Now, Richard, you're nodding. Have you heard of this as well, or does it sound ridiculous to you?
I don't know about diamonds. I've attended a talk in the past, and I desperately wish maybe we'll try and find that and have and see if we can present it, or maybe even contact the author and see if they'd be willing to join. But I've seen a presentation on other planetary weather, and that was fascinating because every other planet in our solar system alone, let alone the universe, in our solar system alone was crazy. The like you say, the types of precipitation that happened, the types of weather, the pressures, the other aspects. So I can certainly believe it. I don't know necessarily about diamonds, but the pressures involved in some places can be extraordinary, and some very low, some very high, and the I know there was some where there was effectively acid was raining from the sky, and like you say, other ones it could be just unfathomable, and was amazing to hear about it. I'll try to see if we can find that sometime and go through that just to show, hey, how special this marble that we live on is really, and the weather we experience.
Yeah, absolutely. That would be a really cool episode. Let's see if we can pull that together. Okay, I think it's probably time for us to move to our fun fact of the week and start to wrap up this week's episode. And the fun fact this week comes from me. I think last week was yours with the link between supermarkets and temperature, which was a really fun fact. Our fun fact this week is that there's some precipitation that falls from the sky, but it never reaches the ground because it evaporates before it gets there. And I'm sure many of our listeners have seen this before. Usually, I think in drier climates, if I'm not mistaken, where the heat coming up from the ground is enough to evaporate the moisture as the precipitation falls before it reaches there. But this is called, got to get this correctly here, virga, right?
It is indeed called virga. Yeah. So virga is a really interesting phenomenon because, as you say, it's precipitation that's falling down through the atmosphere, always from a cloud. So not like diamond dust, for example, but the air below it is not saturated, so you don't have cloud there. First off, and secondly, it is dry enough that as precipitation falls down through it, it's sequentially will start to saturate that air, but it will effectively fall into really dry air. And if the air is dry, then it can absorb heat and moisture, and then it starts to reduce the size of the particle and effectively take some of that energy. And so you'll see that eventually, if there isn't, if the atmosphere isn't so saturated, it will actually dry out completely before it hits the ground. So like you're saying, and that's known as virga. It always indicates convective activity, so you wouldn't find it with stable cloud generally. I'm sure somebody will point me to an exception, but to my understanding, it's always in convective cloud. So it tends to indicate that sort of thing. It has some really severe sort of connotations if it's associated with some particular areas, the continental U.S., for example, particularly over the mid sort of area of the U.S. because of the very warm sort of surface temperatures they can get there, and that warms up the air, and that warm air can hold more moisture. And if you have a thunderstorm that develops in the daytime, then those sorts of virga events can not always, but can be precursors to things called microbursts that can rip the wings off of planes in the wrong circumstances and things like this. So it can be a harbinger of some really challenging weather, but typically I think you find that it's under the bottom of a thunderstorm or under some more rarely mid-level cloud, altocumulus, that you see falling down. And so virga, one that I do happen to know that, and a bit disappointingly, it actually derives from the Latin word virga. So I've always been curious about that one because it was something that I found out when I first started looking at meteorology as an occupation, and then started to observe in some of the spots where I was working, and so I was curious about where that came from. But it actually means that it's if you look at that sort of etymology of that word is either a rod, a spring, staff, branch, shoot, or a twig or spray, that kind of element. So almost like in my mind, I interpret that as almost like a vector coming off of something, an element and that matches well in that sense. It's coming down off the cloud, but it's not reaching the ground. And again, something that is showing the dynamic nature of our atmosphere, that when the cloud is low enough, of course, there's less distance to travel, but what will happen is you get a thunderstorm, and it'll start to rain underneath it, and that will saturate the air below it, even if it wasn't before. And then some slow cloud will either, the base of that cloud will lower, or it'll create its own new layer of cloud, so stratus below a cumulonimbus. And then if it keeps going, then it will effectively saturate those layers as it gets down and then get down to the surface. And that's something that you can see in the real world when you look out with human eyes, as well as in the data sets and in the relative humidity elements that you're measuring and things like this. But yes, I mean, it's quite a special bit of phenomenon. Maybe in another episode we can post a picture or two of it. And and readers, if you have some images, please send them in, and we'll happily look at them as well.
Yeah, exactly. So next time you're out and about and you see some clouds in the sky, have a look up, and you might, on a certain kind of day with the right weather parameters, see some virga falling down from those clouds. I think it's time for us to wrap up this week's episode. So thanks again, Richard, for this. And as ever, time has flown by and I've learned a huge amount. And thank you, our dear listeners, for tuning in to this week's episode of Low Pressure Area. As ever, please remember to like and subscribe so that you can get new episodes when they come out, and let us know your thoughts and comments. We'll look forward to seeing them. Until next time.